Hi, this is Mrs. Zhu, and I do want to apologize that today in class we were unable to complete our notes in class. Our notes were on page 12 of our notebook, and so if you could add one very important topic to the notes from today, as we were looking at the graph, and we either did the Kobe question, Chargers, or we saw the blue whale question. When we looked at those graphs, I started to tell you that if we had a straight line, then that would create a proportional relationship when we go to our graph. So for example, such as this one right here that we did in notes today, if we saw that it was forming a straight line, then I said that it would be a proportional relationship. Or a graph similar to this one right here, where we could create a straight line, or similar to this graph here, where we could create a straight line. Now, actually, in our notes, I would like you to say that a straight line that passes through the origin, and the origin is where our graph will show 0, 0. So at that corner, if it passes through the origin, then the two quantities are proportional. And that's going to help us in our homework tonight. So that whale question, because when the whale was born, bam, he was already 5,000 pounds. Then he progressively, day by day, gained 200 every day. That relationship is actually not proportional. His total gain weight and the days. That's not a proportional relationship. Those quantities are not proportional. If you did the football question with the Chargers, that was proportional. That was constant, 7 points per quarter. That was constant. So let's go ahead and look at number 1 in our homework tonight. We will see that our graph, if we simply draw a straight line and connect the dots, we will get a straight line. We can see from the graph that for every $100 that was donated, then $100 was matched in donation. Okay, so if $0 was donated here, then $0 were matched, which also means that, and we can tell here, like for every $400 donated, 400 was matched. 500, 500. So basically a dollar for a dollar, right? A quarter for a quarter. 0 for 0. So here is considered my origin. The 0, 0 is my origin. And since the graph shows that I have a straight line that passes through the origin, then in this question, yes, my two quantities are proportional to each other. And the reasoning is that definition that I just gave you. The straight line and that passes through the origin. It forms a straight line that passes through. That's kind of like the test. So let's see if all of the other 4 questions do the same thing. So we're going to check B. We've got 3 more questions in the back. So go ahead and try 2 by yourself. I'm going to try letter C. Well, actually, I think you could do C by yourself. Let's try B. B, yes, it makes a straight line. The origin has to be here at 0, 0. And the line does not cross 0, 0. So no, letter B is not, because the two quantities do not cross the origin. Okay? You can do 3 by C, letter C. Let's try number 2, and you're going to try 3 by yourself. We're going to create a table and a graph for the ratio 2, 2, 315, and 111. So we've got 2 to 22, 3 to 15, 3 and 15, and 1 and 11, 1 and 11. Now, they happen to write it in all 3 different ways for ratios, but as we put it into the chart, that's how we would interpret the information. So then on the side, we can draw our own graph to show that relationship and see if they're proportional. So if I have 1, this is my x, my y is on the vertical axis, that's going up and down, 2 and 3. Now the numbers that I have, the lowest number is 11, the highest is 22. So when I go to my graph, I do want to get to at least 22, maybe 25. And I do want to hit 11 somewhere in the middle. So for the y's, I'm going to put 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30, 35. Okay, that's my y's. So from there, when I go to graph, 2 and 22, 2 and 22. Now I happen to not write these in order. I could write 1, 2, 3, and then write 11, 22, 15 if I want. That's okay. I just, the numbers as they appeared, I wrote them on there. There's 222 right here. Then 1, 11, 1 and 11 would be about right here. And then 3, 15 would be right here. Okay. As I look at these dots, I want to see if they are crossing the origin. The origin would be right here. And if they create a straight line. Now, the graph actually kind of just goes like that. And so, is my quantities proportional? Is it proportional? Well, no. Okay. What that means is that there's no constant rate. No constant rate. No straight line. Okay, if it was a straight line, then you would see something increasing constantly, or if it was a straight line going downward, it would be decreasing constantly. But there's no straight line, and it doesn't pass the origin. Okay, it's important it passes the origin. The reason why is when it does pass the origin, we know that there is something is constant, and that unit rate will increase at that rate every time, whether increasing or decreasing. So if it doesn't pass through the origin, then we know that if it's at 0, 0, it's probably not going to be constant, okay? Because it could have started at like the whale starting at 5,000 pounds. Try 3 and 4 by 3A and B by yourself. Put it on the graph, see if it's straight line and if it passes through the origin, and if it does, you will know that it's constant, that it has a proportional relationship to each other. Enjoy your day. Rewind as you need to. And if you want to try 3A and B by yourself, you can pause here on the video, because then I'm going to say the answers so that you can double check that to know that you're on the right track. Now I'm going to tell you the answers for 3A and B. So pause it if you didn't pause so you can check your answer. It was yes and then no. I'm not going to put the dots on the graph. We could check that tomorrow. See you tomorrow.